Surface areas and volumes, exercise 10.4 part 3. Seventh problem. The diameter of a spherical balloon increases from 14 centimeters to 28 centimeters as air is being pumped into it. Find the ratio of surface areas of the balloons in the two cases. So here the diameter before and after the air is pumped is given. So diameter D1 equal to 14 centimeters, diameter D2 equal to 28 centimeters. So what is the radius? R1, it is D1 by 2, that is 14 by 2, 7 centimeters. This is the radius before pumping the air. Radius R2 equal to D2 by 2, which is equal to 28 by 2, 14 centimeters. This is the radius R2 after pumping the air. So let us find the ratio of radii. R1 is to R2 equal to 7 is to 14, which is equal to 1 is to 2. So what is the ratio of surface areas? The formula for surface area is 4 pi r square. So 4 pi r1 square is to 4 pi r2 square. 4 pi cancelled. R1 square is to R2 square is equal to 1 square is to 2 square, which is equal to 1 is to 4. This is the ratio of surface area of the sphere before and after pumping the air. A hemispherical bowl. A hemispherical bowl is made of brass 0.25 centimeters thickness. This is the thickness of the bowl. The inner radius of the bowl is 5 centimeters. Find the ratio of the outer surface area to inner surface area. Okay. Here we know the inner radius Ri equal to 5 centimeters. What is the thickness? It is 0.25 centimeters. So what will be the outer radius? We have to add this thickness to the inner radius to get the outer radius. Therefore, outer radius RO equal to Ri plus thickness. That is equal to 5 plus 0.25, which is 5.25 centimeters. Ratio of surface areas AO is to A1. AO is to AI. So because he has asked to find the ratio of outer surface area to inner surface area. So ratio of surface areas AO is to AI equal to 4 pi RO square is to 4 pi RI square. Okay. So let us substitute the values of the inner and outer radius here. So outer radius first 5.25 whole square is to 5 square. So 27.5625 is to 25. So after removing the decimals and simplification, the ratio becomes 441 is to 400. So this is the ratio of the outer surface area to inner surface area. Next problem, ninth problem. The diameter of a lead ball is 2.1 centimeters. The density of the lead used is 11.34 grams per cm cube. What is the weight of the ball? Here density is expressed as grams per cm cube. That means density is mass by volume. So diameter D is given 2.1 centimeters. Radius R equal to D by 2. So that is equal to 2.1 by 2, which is equal to 1.05 cm. So let us assume that the mass of the ball is x grams. So volume is 4 by 3 pi r cube for sphere. So let us substitute the values 4 by 3 into 22 by 7 into 1.05 into 1.05 into 1.05. So after simplification, this is 4.851 cm cube. This is the volume. Now we know the volume and we know the density. So density is mass by volume. So 11.34 equal to x by 4.851. After substituting the values of density and volume, this is the equation. So x equal to cross multiply 11.34 into 4.851. Therefore x equal to 55.01034 grams, which is equal to, after converting into kilograms, 1 kg equal to 1000 grams. So after conversion, this becomes 0.055 kg. So weight of the ball is 0.055 kg or 55 grams. Like, share and subscribe for more interesting maths videos on surface areas and volumes.